constant. Okay, right. In this one, we defined, sorry, in the second example, we defined the nth term in terms of the preceding one, the one before it, and the one before that. Okay, and then in the final example that I have here, I've defined the nth term in terms of the previous one plus the product of the previous one times the one that precedes that. Okay, so this is where things, I suppose, uh, this is where these key terms come into play. Let's say we have the key term linear that we need to understand. We have, let's say, the key term homogeneous, right? And let's say we have the key term degree, the degree, right? And let's say we have constant coefficients, right? Coefficients, right? That's important, okay? So just to get back to our definition, okay? So we said that recurrence relation in general, right? A linear homogeneous, right? Recurrence relation with constant coefficients, constant coefficients, right? Okay, with constant coefficients looks something like this. The nth term is defined in terms of possibly some constant times the previous one, okay, plus some other constant times the one that precedes that. And we can keep going out to how many terms is this? The first, second, third, to fourth. Let's say to the kth term times a to the n minus k. Okay, so by linear we mean this. Okay, so linear effectively means this is that the terms that the an's, let's say, okay, so that the linear basically means that the an minus 1, okay, or and the an minus 2 all the way, and the an minus 3 all the way down to the an minus k, that these particular, let's say, factors in here for each term, okay, that each term is only composed of those particular values. Okay, so that these appear, that each one of these basically, uh, let's say, appear, okay, in separate, okay, or different in separate terms in the recurrence. Okay, that's what it means to be linear. Okay, so for example, when we go back to the examples that we had, okay, let's say, where's the first example? Okay, so you can see the first example, yeah, okay. Well, the only thing that's appearing, the only term that we have here is an an minus 1, and it only appears there, yeah. So this is linear by definition. Okay, let's have a look at the second example that we had. So the second example, uh, we had the recurrence uh, was an is equal to an minus 1 plus 3 times an minus 2. So don't forget the terms are anything separated by an equals and a plus. So this is a term, and this is a term, and you can see that the preceding terms to the nth term, yeah, only occur within the terms themselves. Okay, so this is linear. What about this example over here? Okay, so well, that was actually the calculation of that. Let's have a look at this one here. Okay? This is a term, and this is a term. Okay, this term has a has a has one of the preceding terms in it, but look, this one has two of them. Okay, it's the product of them. Yeah, so this is not linear. Okay, so to be linear, okay, the terms, okay, can only appear as as components in in these particular things on their own. Okay, so we can't have the product of them. We can't have anything else. We can't have multiple terms multiplied by each other within here. So that's what it means to be linear. Okay, what does it mean to be homogeneous? Uh, well, homogeneous is basically that the degree that the degree of each term, okay, the degree of each term, okay, is the same. Okay, is the same. So actually what we have here is this, is that when we look at this one here, what we mean by the degree, okay, is that, well, effectively, this is to the power of 1. This is to the power of 1. This is to the power of 1. Okay? All of them have the exact same power, so we say it's homogeneous. Yeah. Okay? In contrast to, let's say, in contrast, okay, to, so let's say in contrast to, let's say, a of n is equal to c1 times a of n minus 1 plus c2 times a of n minus 2 squared, okay, plus all the way down to, let's say, c of k times a of n minus k even to the 1. So all of them are the same except for the second one, yeah, but we have a square, okay? So it's not homogeneous in this particular instance, yeah? Okay? For it to be homogeneous, all the terms have to have the same degree. They have to be raised to the same exponent. And we could make this homogeneous by making them all squares. Then it's homogeneous, okay? Okay? It's homogeneous. Now, homogeneous also means